My name is Seán Kavanagh, and I'm originally from Dublin, Ireland, but I'm now studying in London, England, where I'm a PhD student in the research groups of David Scanlon at University College London and Aaron Walsh at Imperial College London. So our research uses computational modeling to understand the atomistic properties of solid-state energy materials, such as batteries, thermoelectrics, and solar photovoltaics, for example, and to then leverage these insights to optimize performance. And this was the research for which I received an MRS Graduate Student Award, where we collaborated with an experimental group in Barcelona who were developing solar cells using silver bismuth sulfide, this sort of ternary chalcogenide material. And by understanding the impact of disorder in this material, we were able to determine the optimal synthesis conditions for performance, which then gave record-breaking efficiencies. We actually achieved the highest efficiency of all bismuth-based solar cell materials and the strongest absorption of all currently studied solar cell materials, which is, of course, a key component for a solar cell. So this actually allows us to make ultra-thin solar cells with this material, so only like 30 nanometers thick, making them ideal candidates for lightweight, flexible, non-invasive applications, so such as in clothes or wearable electronics, powering smart devices, or in space, for example. So there are a lot of exciting ongoing developments in the field of computational modeling. And so I think the field will change a lot in the next 10 years. The combined advances of more accurate and more efficient methods, such as machine learning or in electron phonon interactions and models for those interactions, as well as rapidly growing computational power, will allow us to more accurately and more efficiently screen vast chemical spaces for identifying candidate materials for energy applications, as well as more accurately predicting their actual performance by now including the effects of defects, grain boundaries, carrier mobilities, trapping, etc., which were previously inaccessible to computation. And so I think that's really exciting for the field. As for where I see myself in 10 years, that's a trickier question. I love what I do, and it definitely doesn't feel like work. So I really hope to stay in academia and aim for a permanent research position. So hopefully I'll be attending the MRS spring and fall conferences each year for the foreseeable future. I think I'd like to be based in the United States or in the UK, though I have a long-term partner, meaning I also have the so-called two-body problem to consider. There are a lot of strings attached when it comes to pursuing a career in academia, particularly when it comes to work-life balance. And if I'm being honest, the reputation of some places on this front has put me off going there. I'm certainly not productive or happy if I'm not taking breaks and enjoying myself, or if I feel like I'm forced to work long hours. And I certainly don't have the mental space to produce valuable scientific insights if that's the case. So if we continue this way, I think we're selectively encouraging quantity over quality and driving some of the best minds in science away just because they don't want to sacrifice life outside of research. So I think this is something as a community we need to recognize and work to promote a better working environment for ourselves and future generations.